Hello everyone, this is Eren Şahin. I'm a sales engineer from liNear in Istanbul. Today I will give you information about how to work with liNear solutions on Revit interface. If you are a Revit user or you are planning to work with Revit, you can see how to work smarter instead of working harder. In cooperation with the industry, liNear offers its customer extensive CAD libraries. This allows you to design your project using the actual manufacturer components, thereby greatly increasing the benefit of our material and order lists. The different CAD libraries are available in 2D and 3D. All data have been verified by the manufacturers and therefore guarantee a safe and effective design. A one product family is automatically created as part of Revit integration. As you see in the liNear CAD browser, there are different manufacturers. For example, if you want to insert a component or replace the ones in the project, you can select the manufacturer and the component from here. Let's select a manufacturer. As you see, in this manufacturer, there are this kind of products. When you select one, you can find the exact component that you need in your project. In here, you can see the preview of this component. Also, in here, you can find its technical data. And also, you can select the CAD platform and you can select either you want to place it, insert it, or replace it. And with this command, you can select the level of detail that you want to see in your project. The liNear desktop makes Revit a real MEP tool. Not only the comfortable provision of our tools, but also the sorting, bundling, and simplification of the Revit functions is our approach. Logical view management and creation, clearly organized libraries, one-click visibility control, collaboration tools, and discipline-specific toolsets are just some of the benefits of the liNear desktop for Revit. Depending on the selected discipline, you may find suitable functions such as the drawing pipes or ducts command, connection commands, parallel pipes, pipe offsets, transitions, laying areas, and spaces. In the system selection, you are offered the system that have been assigned to the relevant discipline within the system table. The selected system type is then automatically applied during construction. From the combination of currently selected building part, story, discipline, and the view type, liNear desktop will create views with all the settings that enable you to see exactly what you intended to see and moreover, how you want to have it displayed. The views are automatically sorted and offered according to the selected discipline. You may select a discipline and leave it to the program to search for suitable views. In order to create a view, liNear asks us three questions. First of it, where? So we select where do we want this view. In this case, we select the building part as main building and then we select the story. We select here the ground floor. The second question is what? So we select what discipline do we want to work on. You can see all disciplines of liNear in this menu. And here we select the architecture. And the third question is how. So we choose what type of view do we want to create. And here we can create a 3D view, or a floor plan, or a ceiling plan, or a section view, and so on. We select the floor plan. And then, when we click on this green plus sign in here, this menu pops up, and then in here we can select another discipline and the level of geometry that we want to work on, and then we can name this view. Let's name it 2 because we already have this kind of view. And we say create view. As you can see, this floor plan has been created, and in this menu we can see all views that has been created for this project. And when we change the discipline, for example, if you click on heating, we can see all views that can be used in heating discipline with the green check sign. And when we click on this, it will open this floor plan in a heating discipline. Integrated design means that even in the early design phases, all parties involved work together on the concept of the building. With our tools for the design, dimensioning and placement of equipment rooms and supply pipeline corridors, you have the possibility to optimize the installation of the design building services in collaboration with other trades already in very early design phases. The resulting initial effort is more than compensated in subsequent design stage by reduced friction points and shortened revision planning. With the tools, you can determine a realistic space requirement for the equipment rooms and coordinate this with other parties involved in the early design stage. This enables active conflict avoidance instead of costly changes having to be made in the course of conflict resolution in the later design process. The space required by the equipment rooms of the individual trades can either be determined quickly and easily in accordance with the rules of VDI 2050 with just a few specifications or specified based on experience. The equipment rooms can then be placed in the model as provision for space, and the space requirements can be compared with the available space in a conceptual architectural model. The export of the equipment rooms by means of IFC enables quick and easy coordination with the architect. When specific MEP information have been added to the architectural model, it is ready for design and analysis. The model can be transferred to linear building automatically. With linear solutions, you don't have to add all components manually in another interface. As long as you complete the Revit model with its thermal properties, linear will detect these values, and the program also checks the model and reports any missing values. Missing data, for example U values, can now be manually added or calculated. You have the choice whether you work with self-defined values or whether these are replaced by better values as soon as they are available. All values can also be transferred back into the model. The representation of the model in building parts, levels, and rooms enables quick and easy orientation. The detected building model is the basis for all load calculations and dimensionings. Linear building modules not only used for heat load calculations, but also you can use them for dimensioning and creating layouts of panel heating and cooling circuits, radiators, and convectors. The dimensioning and layout are based on thermal calculation results. liNear will automatically find the optimum solution according to the based condition that given by the user. You may select these components from manufacturer library with their catalog data, and they will be used in material list. For an MEP planner, liNear is a very easy to use software with its intuitive interface. liNear menu will direct you step by step for each workflow, and if you make a mistake, it will show you the exact location and cause for you to fix it. But still, if you need more information about commands you're using, liNear has a context-sensitive help interface. In Revit menu, you can easily click on information and click on this help command, and it will open on this interface on a web browser, and in here you can find detailed explanation about each subject. For example, if you want to learn more about heat load calculation, about a specific standard, it will give you some explanation about this. Or if you are going to have information about constructing networks, pipes and ducts, and you will see the detailed explanation about the menu, and you can find every information in here. And also, you can go to a specific discipline, and when you click on this question mark, and for example, let's select the system class, and it will show you the details on system class. Also, in linear building, we have the same option. We can click on help in here, or we can easily press F1 to reach this menu, and these titles are specifically for linear building software. And as you see, these topics are categorized on the basis of the workflow, and you can choose between getting started, analyzing building, dimensioning components, inserting components, and having output. Hydraulic calculations are necessary for us to understand the network for each MEP discipline. With our Analyze tools, you can have all calculations, pressure losses, sound calculations, simulations, pipe and duct dimensions, and so on. And these calculations will be based on basic conditions you determine, such as maximum velocities, pipe friction pressure, and valve authorities. Because linear software is widely used in the service departments of our industry partners, we have to cover a lot of specialties that result from their constantly improving product portfolios. Now I will tell you about some of our specific components and calculation parameters for each discipline. For heating systems, we have multi-boiler systems, hydraulical separators, hydraulic balancing of complex system with nested control levels and different temperatures in the network, 6-way valves for switching, heating and cooling. Let's see this project as an example. If we check the heating and cooling system in 3D, as you can see, there are convectors placed for heating and cooling. Here is our boiler. And this one is a freshwater station. And there is the expansion tank. And they are connected to a manifold. And if we follow a flow path, we will see these pipes are connected to a 6-way valve. With this way, this system can be used for heating and cooling. And the system type for these pipes are supply and return water for heating and cooling networks. Also, there is another connection from the boiler to the heater in the central ventilation device. The heated water that comes from boiler will go up to the coils inside of this component to heat the air. And all of these components are taken from linear product libraries. You can select these components with real manufacturer data or as neutral Revit family. In order to apply a hydraulic analysis on this project, we need to set some basic conditions. When we go to the Analyze tab and click on Configuration command, we can see there are some different options and values. These options are to determine the reaction of our Analyze module. For example, there are these options such as hydraulic balancing after calculation, dimension pipes decreasingly, determine pipe heat losses, detect material with every calculation, and label XP values. These options are clearly indicating their functionality. And these values are here to set some limit values for our calculations. These are maximum pressure loss for thermostatic radiator, tolerance hydraulic balancing, permitted pressure excess for differential pressure in closed loop controller, maximum permitted error mass flow rate percentage for one pipe connector, supplement pipe volumes for fitting and valves, and the ambient temperature. And in basic conditions, we can set these values for dimensioning pipes. As you can see, there are different options. You can dimension the circuit based on maximum velocity and pressure. You can only select the pressure like this, or both of them in the same time. And you can give these limit values for pressure dependent on the nominal diameter, like this. Also, you can use valve authorities as a basic condition for thermostatic valves. You can either use the real valve authority or the conventional valve authority. Other options are here to set limit values for regulating valves and differential pressure closed loop controller. As you can see, there are preset values. We can use them or change them. It's totally up to you and the project. Now let's see the potable water network for this project. When we go to the project tab and double click the potable water, it automatically shows us the 3D view. For potable water systems, we have venturi nozzles for driving potable water systems, inliner and asymmetrical circulation systems, automatic flushing system for hygienic potable water, temperature time functions for section parts, an entire network in consideration of insulation and ambient temperature, dwelling and decentralized freshwater stations, pressure boosting station, and pressure closed loop controller with output pressure specifications. And for this project, if you want to see a floor plan, we can navigate in the View Manager and select the Floor Plan tab. When we click on this, it will show us the floor plan for the ground floor. If you want to see another floor plan in another floor, we can easily click and we can see the floor plan for the first floor. Now let's go back to our 3D view. In this 3D view, we can see the network more clearly. The cold water pipe starts from here. We can see the water meter, a filter, and some valve installations. The pipe goes all over to the freshwater station right here. Here, the water will be heated and distributed to the consumers. If we check out its technical data, we can see the hot water temperature, pressure loss for heat exchanger, and so on. As you can see, there is no water meter inside of this component, and the pump is included in the device. From here, the hot water is distributed, and we also have the circulation pipe goes along with the hot water pipe. All components, pipes, and pipe accessories in this system are from liNear product libraries as well. And for the construction, we use liNear desktop module with automatic routing and connection commands. When you go to the Analyze tab right here and click on Configuration, as you can see, there are the basic conditions for calculations. Under the calculation parameters, we can select the standard that we will use in this calculation. If we change the standard, liNear will show us the modifications upon method change. And when you select another standard, some of the options in here will disappear. After we select the standard, we have to enter some data in order to apply the calculation. For example, we should select the type of the building. And in here we select the global usage, we select temperature, we select minimum and maximum values for pressures and volume for cold water and hot water. And in here we also have another options that we can check or uncheck them. And if we go to this side, we see the maximum velocities for host service, connection pipe, consumption pipes, continuous supply pipelines, and flexible pipes. And under this, we can also do some selection about material detection and visualization. And in here, we can select if we want to calculate the ejection time or not. And under this, there are actually calculation methods for ejection times. And after we completed to do our selection for these basic conditions based upon our preferences, we can say OK, and then we can apply our calculation. And now we will continue with the wastewater systems. For wastewater systems, their aeration ducts are tested and certified according to standards, dimensioning of rainwater pipes with reference to the statistical rainfall rate according to DIN standard, and consideration of wastewater lifting stations. Now we will select the wastewater discipline right here and then move to the Analysis tab. When we check out the configuration, in this first tab, you can determine the general settings, such as system types and component detection. In second tab, there is a drainage settings. Here, you select the calculation method or the standard in order to calculate this network. And in here, you can select the type of the building. And this is necessary in order to calculate in this method. And here we have some basic conditions. You can check or uncheck like all branches have an inside radius, ground pipes behind lifting stations with increased filling level, ground pipes behind open pit with increased filling level. And when you check this, like ignore drawn slopes, liNear will calculate the slopes even if you don't draw them. And if you uncheck them, you can also have another option, and it says that when the drawn slope is too small, insert a minimum slope. And also here we have allow a minimum slope for 1 over nominal diameter for exterior ground pipes. And in here we can give another data for minimum slopes. Here there are types of wastewater pipes, and this value should be centimeter per meter. Also, we have toilet presettings. You can set the flushing quantities here. If you change the method to another standard, you can see some of these options might be disappeared. And in this way, liNear directs you to enter right amount of data and avoid time losses. And in the third tab, you can determine the rainfall rate. Here, you can use the Costra software, or you can load a rainfall rate data, or you can fill this table by yourself. And as you see, there are other options for this data as well. You can enter the calculated rainfall rate, open area rainfall rate, and over 5 minutes long rainfall rate from here. And now we will continue with our Analyze Ventilation module. Here we select the ventilation discipline. And here you can see the ventilation system. With linear Analyze Ventilation, you're not only able to do the pressure loss calculation, but also you can apply a sound level calculation through all systems at once with automatic sound level results for each room. Here you can see the central ventilation device. And this device is configured with linear device configurator. You can find it in here. With this command, you can select all components and create one big central ventilation device. And this device is connected to these slot diffusers with these ducts. All of this construction is made by linear desktop module. Here you can draw all types of ducts, and then you can use this command to easily construct your system. And for these components, you can go to the library tab and you can select them in wide variety of components. And in here we will reach the analysis tab. First I will show you the rooms command. When you open it, you can see all 64 rooms in this project. When you select the room, you can see its dimensions, its temperatures and air humidity results, its spatial and room type for sound level calculations. And in here you can see the air outlet, the slot diffuser, and you can see the airflow rate of this slot diffuser. From this command you can determine the target values from different methods, and you can assign all slot diffusers or air outlets to all of these rooms. And the sound level and pressure losses will be calculated based on these parameters. And now we will go to the configuration command. You click on this. As you can see, it has 3 different tabs. The first one is component detection. Here you can see the system types, and when you click on one of them, you can select the system types and components that will be detected by linear Analyze Ventilation. And in here there are calculation presettings. Here you can select the density, you can select the dimensioning presettings by topology or according to volume flow rates, and also you can consider the pipe friction pressure loss, or you can uncheck these presettings by one, or you can use both of them. And in here you can select the outside air temperature and outside air humidity. And these are also another basic conditions that you can use in your calculation. And in the third tab you can find the duct dimensions. And here you can determine the basic conditions of duct dimensions, and as you see it is separated by rectangular and pipe oval duct. And now we will calculate the system. The calculation dialog is categorized in three titles. They are flow paths, section parts, and components. Under flow paths, we can see the flow path from the source to the consumer. And the critical flow path is marked in yellow color. And in here, you can see the pressure losses and volume flow rates. Under section parts, you can find the section parts on this flow path. This dimensioning is made based on applied calculation. Under the components, you can find the components on this flow path and this section part. When you click on Show, it will show you the part that you have selected in the calculation dialog. If you click on Search, you can select a component and you can see it on this list. And when you click on Edit, you can see all technical properties and calculation results. For a swirl diffuser, you can see the room data, pressure losses, and sound level calculation results. And you can edit concerned parts. In here, if you click on Visualization, you can color the network for different parameters. If you select the air velocity and click on Display, it will color the network on a spectrum from red to blue. And if you click on, for example, duct dimensions, when you say Display, it will color different duct dimensions in different colors. You can see in here. Also, you can see that the report button is an orange color. This indicates that the program gives us some notifications and warnings. And this one, for example, is about the port, and it says that for the virtual branch, zeta values were determined on the basis of adapted cross-section shapes. And if there were an error, the report button would be in red color, and we needed to fix this error to balance the network hydraulically. So let me draw a conclusion about the advantages of our software. First of all, it's the complete portfolio, construction and calculation from one vendor for all relevant disciplines. It reduces the number of error-prone interfaces, and it eliminates discussion about who is responsible if things don't work as expected. The second, is modularity. We see that it's not sufficient to offer just one product for piping and another for ventilation. With the structure of our product portfolio, you can combine exactly what you need for your project or work. And whatever module you initially buy, you make the first step into a scalable solution. And this means that you can have one module right now, and then in future you can combine that with other modules and disciplines. And the third one is workflow approach. To support a good learning curve, it is not enough to just fill another Revit ribbon with some icons and buttons. Making the right tools accessible at the right time is what speeds up your work. So our workflow-based user interface approach helps you to be productive right from the beginning. And finally, dedicated calculation software for qualified engineers. Hydraulical calculations for engineers are much too complex to be expressed by a simple pressure loss formula. Calculation of different systems is very different and must meet the requirements of standards. In combination with manufacturer data sets, the results are much closer to reality. It is worth to mention that our industry partners themselves use our software solutions to support their customers who are installers as well as MEP designers. And of course, we support third-party or self-created Revit families within our calculation modules. We have come to the end of this webinar. I am happy in this 40 minutes I could show you some major advantages of the linear solution for Revit in terms of productivity as well as the high quality level of our calculations for MEP professionals. If you have any opinions on our webinar or if you have any suggestions for topics that we should cover in our next webinars, please let us know. If you need more information about this subject or linear, you can reach me via esa@linear.de. If you want to watch this or previous webinars again, you can follow linear YouTube page. In linear international YouTube page, you can find more detailed videos about our analyzed modules. Thank you very much for your participation.